Imagine being told you'll never achieve anything remarkable. As a child, he was quiet, shy, and often misunderstood. Some teachers believed he wasn't particularly gifted, and after graduating from university, he couldn't even find a job as a teacher. Instead, he spent his days working in a small patent office, reviewing other people's inventions. But behind that ordinary desk, one man was quietly reshaping the future. His ideas would completely change the way we understand space, time, gravity, and even the universe itself. They would help lay the foundation for technologies we use every day, from GPS navigation to modern physics. Albert Einstein was born on March 14, 1879, in the city of Ulm, in southern Germany. At the time, nothing about his early life suggested that he would one day become one of the greatest scientific minds in history. He grew up in a middle-class family. His father, Hermann Einstein, was an engineer and businessman, while his mother, Pauline, encouraged his love of music. As a young boy, Albert learned to play the violin, a hobby he would continue throughout his life. Unlike many children his age, Albert wasn't interested in simply accepting how the world worked. He constantly asked questions that others rarely thought about. Why does a compass always point north? What makes light travel through space? What invisible forces shape the universe around us? One of the most important moments of his childhood came when his father showed him a small pocket compass. Albert was amazed that the needle always pointed in the same direction, even though nothing visible seemed to move it. That simple object sparked a lifelong fascination with the hidden laws of nature. Despite his incredible curiosity, school was not always an enjoyable experience. The education system at the time emphasized strict discipline and memorization, leaving little room for imagination or independent thinking. Albert often challenged authority, questioned his teachers, and preferred solving problems on his own rather than following rigid classroom rules. Contrary to a popular myth, Einstein did not fail mathematics. In fact, he excelled in math and physics from a young age, mastering subjects that many older students found difficult. His real struggle wasn't intelligence. It was fitting into a system that discouraged curiosity. As the years passed, his passion for science only grew stronger. Books on mathematics and physics became his constant companions, and he spent countless hours imagining questions that had never been answered. Little did he know, those endless hours of curiosity were preparing him for discoveries that would one day change humanity's understanding of the universe forever. In 1896, Albert Einstein enrolled at the Swiss Federal Polytechnic School in Zurich, determined to study mathematics and physics. It was here that he sharpened his scientific thinking and met many of the people who would influence his future, including a fellow student named Mileva Maric. Einstein graduated in 1900 with high hopes of becoming a university professor, but reality was far less encouraging. Despite his outstanding ability, he struggled to find a teaching position. He applied for job after job, only to be rejected time and again. For nearly 2 years, he survived by taking temporary work as a tutor, giving private lessons while continuing to study physics whenever he had the chance. It was a frustrating time. Many young scientists were building academic careers, while Einstein was still searching for a place where he belonged. Then, in 1902, an unexpected opportunity changed the course of his life. Through a friend's recommendation, he was offered a position as a technical examiner at the Swiss Patent Office in the city of Bern. At first glance, it seemed like an ordinary desk job. Every day, Einstein reviewed patent applications for new inventions, carefully examining how different machines and electrical devices were supposed to work. But what looked like a career detour became the perfect environment for deep thinking. Once he finished his daily work, his mind wandered to much bigger questions. He imagined riding alongside a beam of light. He wondered how time would behave if objects moved at incredible speeds. He questioned ideas that most scientists of his era simply accepted as fact. Without the pressure of university politics or the demands of teaching, Einstein spent evenings filling notebooks with bold ideas and thought experiments. He wasn't surrounded by expensive laboratories or complex equipment. His greatest tool was his imagination. Few people noticed the quiet patent clerk working in Bern. To the outside world, he was just another government employee. But inside his mind, a scientific revolution was taking shape. The year 1905 was about to change not only Einstein's life, but humanity's understanding of the universe forever. The year was 1905. Albert Einstein was just 26 years old. By day, he was still working at the Swiss Patent Office, living a quiet life that gave no hint of the extraordinary ideas taking shape in his mind. Then, in the span of just a few months, he published 4 scientific papers that would forever change the course of modern science. It was a level of achievement so remarkable that historians would later call 1905 Einstein's miracle year. His first paper helped explain a strange phenomenon known as the photoelectric effect. It suggested that light wasn't just a wave, as many scientists believed, but could also behave like tiny packets of energy called quanta. This groundbreaking idea would later become one of the foundations of quantum physics. His second paper offered convincing evidence that atoms truly existed. At the time, some scientists still questioned whether atoms were real. By explaining the random movement of tiny particles suspended in liquids, a phenomenon known as Brownian motion, Einstein gave the scientific community powerful proof that atoms were more than just a theory. Then came the paper that would make his name unforgettable. Einstein introduced the world to the special theory of relativity. He proposed something almost impossible to imagine, that space and time are not fixed. Instead, they are connected, and they can change depending on how fast an object is moving. According to Einstein, time itself could slow down, distances could shrink, and two people moving at different speeds might experience time differently. These ideas challenged centuries of scientific thinking and completely transformed how we understand the universe. From this revolutionary theory came one of the most famous equations in history, E equals mc squared. Though it looks simple, the equation revealed an astonishing truth, that mass and energy are different forms of the same thing. Even a tiny amount of matter contains an enormous amount of energy. This discovery would eventually influence everything from nuclear energy to our understanding of how stars shine. Almost overnight, scientists around the world realized they were witnessing the work of an extraordinary mind. The unknown patent clerk from Bern was no longer just another government employee. He had become one of the most exciting thinkers in modern physics. But Einstein was only getting started. His greatest breakthrough, the one that would redefine gravity itself and make him a global icon, was still years away. Although his discoveries in 1905 amazed the scientific community, Albert Einstein believed there was still one great mystery left to solve. For centuries, scientists had understood gravity as a force that pulled objects toward one another. But Einstein wasn't satisfied with that explanation. He wanted to understand why gravity existed and how it truly worked. After nearly 10 years of relentless thinking, calculations, and countless failed attempts, he finally unveiled his answer in 1915, the general theory of relativity. The idea was unlike anything the world had ever seen. Einstein proposed that gravity wasn't simply an invisible force pulling objects together. Instead, massive objects like planets and stars actually bend the fabric of space and time around them. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet curves under the weight, and smaller balls roll toward it. In a similar way, Earth orbits the sun not because it is being pulled by an invisible rope, but because it follows the curved path created by the sun's immense mass. It was a bold and revolutionary idea, but proving it would be another challenge entirely. That opportunity came in 1919 during a total solar eclipse. An expedition led by British astronomer Arthur Eddington measured the positions of stars whose light passed close to the sun. Just as Einstein had predicted, the sun's gravity bent the starlight. The results made headlines around the world. Newspapers declared that a new scientific genius had rewritten the laws of the universe. Almost overnight, Albert Einstein became one of the most recognizable people on Earth. His wild hair, thoughtful expression, and brilliant mind turned him into an international icon. In 1921, Einstein was awarded the Nobel Prize in Physics. Interestingly, he did not receive it for the theory of relativity, which was still considered controversial by some at the time. Instead, the prize honored his explanation of the photoelectric effect, work that would later help pave the way for modern electronics, lasers, and many technologies we rely on today. By the early 1920s, Einstein had become far more than a scientist. He was a global symbol of intelligence, curiosity, and the limitless power of human imagination. But as his fame continued to grow, dark clouds were gathering over Europe. Political unrest was spreading across Germany, and events beyond Einstein's control would soon force him to leave his homeland forever.
By the early 1930s, Germany was changing rapidly. The Nazi Party, led by Adolf Hitler, had risen to power, and Jewish families across the country faced growing persecution. As a Jewish scientist and an outspoken critic of the Nazi regime, Albert Einstein knew it was no longer safe to return home. While traveling abroad in 1933, he made the life-changing decision to remain outside Germany. He eventually settled in the United States, accepting a position at Institute for Advanced Study, where he continued his research. But the world was on the brink of war, and a new fear was emerging. Scientists had discovered that splitting atoms could release an enormous amount of energy, the very idea hinted at by Einstein's famous equation, E=mc². In 1939, Einstein signed a letter addressed to U.S. President Franklin D. Roosevelt. The letter warned that Nazi Germany might be developing an atomic bomb and urged the United States to take the possibility seriously. That warning helped draw attention to nuclear research, which eventually led to the creation of the Manhattan Project. However, Einstein himself did not work on the project. Because of security concerns and his outspoken political views, he was never given a role in building the bomb. In 1945, the United States dropped atomic bombs on the Japanese cities of Hiroshima and Nagasaki, bringing World War II closer to its end, but at a terrible human cost. In his later years, Albert Einstein never stopped asking questions. At the Institute for Advanced Study in Princeton, he spent much of his time searching for what he called a unified field theory, an ambitious attempt to explain all the fundamental forces of nature through a single, elegant framework. Although he never succeeded, his determination reflected the same curiosity that had driven him since childhood. Outside the laboratory, Einstein became a powerful voice for peace, international cooperation, and human rights. He spoke against war, warned about the dangers of nuclear weapons, and supported equal rights for all people, believing that science and humanity should always move forward together. Despite becoming one of the most famous people in the world, Einstein remained remarkably humble. He often reminded people that curiosity was more important than simply having all the answers. One of his most memorable quotes captures this perfectly. "I have no special talent. I am only passionately curious." On April 18, 1955, Albert Einstein passed away in Princeton, New Jersey, at the age of 76. The world had lost one of its greatest thinkers, but his ideas were only beginning to reveal their full impact. Today, Einstein's theories are used in ways he could scarcely have imagined. GPS satellites account for the effects of relativity to provide accurate navigation. Astronomers use his work to study black holes, gravitational waves, and the expanding universe. Technologies based on his discoveries continue to shape modern life in ways that most people never notice. More than 7 decades after his death, Albert Einstein remains a symbol of imagination, curiosity, and the courage to challenge accepted ideas. His story reminds us that the greatest breakthroughs often begin with a simple question: what if everyone else is wrong? Albert Einstein didn't just change science, he changed the way humanity sees the universe. He proved that curiosity can be more powerful than convention, that imagination can unlock the deepest mysteries of nature, and that one person, armed with nothing more than questions and determination, can leave a legacy that echoes through generations. From the movement of planets to the technology in our smartphones and GPS systems, Einstein's ideas continue to shape our world every single day. His life is a reminder that greatness isn't defined by where you start, it's defined by your willingness to keep asking questions, even when the answers seem impossible to find. If you enjoyed uncovering the incredible story of Albert Einstein, be sure to subscribe to The Globe Uncovered for more fascinating documentaries exploring the lives of extraordinary people and the remarkable stories of countries from around the world. Until next time, keep exploring, keep learning, and keep uncovering the world.